We're looking at graphing quadratics here, and we're going to use the calculator to help us. So it's going to be pretty easy, but we do need to know what we're looking for. We have to make sure our graph has the correct shape. And when we're dealing with quadratics, it's going to be that U shape we call a parabola. We need to make sure we've got the vertex, we've got the y-intercept, and we've also got the x-intercepts if there happen to be any. Not all parabolas have x-intercepts. So start with the vertex. V, the vertex equals the x-coordinate is negative b over 2a, and we'll worry about the y-coordinate later. The b and the a are the same as the ones we use in the quadratic formula. So b here is going to be negative 8, and a is going to be the one that we don't have written there. So negative of b, which is negative 8, over 2 times 1 is 4. That's the x-coordinate of our vertex. And if we were to plug it into our equation here, if we were to plug it into our formula, we could find the y-coordinate fairly easily, but let's let the calculator do the work for us here. We now know that the x-coordinate's of 4, and that's going to be helpful to us. So pop this in the calculator, right? Go to your y equals screen, x squared minus 8x plus 12. And then go to the graph screen, and we should get a nice picture of our function. Now we want to know the y-intercept. So go to trace, put in 0 if it's not already there. 0, 12 is our y-intercept. And that looks about right. Looks like it crosses the y-axis a little above 10 there. What I want from you, 2, 4, 6, 8, 10, 12, is to put a point right there. You don't need to label it or anything. If you put a nice dot there at 0, 12, I'm going to know that you know that that's the y-intercept. The vertex we know has an x-coordinate of 4. So if we put in 4 and hit enter, trace tells us that the y-coordinate is negative 4. So we've got our vertex at 1, 2, 3, 4, and then down 1, 2, 3, 4, right about there. Looks like we've got x-intercepts at 2 and 6. Let's double check that. We're still in trace. If we put in a 2, do we get 2, 0? Yes, we do. Do we get 6, 0? Yes, we do. So there's our x-intercepts. Right at 2 and right at 6. Sorry, a little bit off my screen there. And we want to make sure we've got the right shape for this guy here. You may want to look in your table for a couple extra points. I happen to know if you go over 1, up 1 from your vertex, you have a couple more points there. And then it's going to go through 1, 5 and also 7, 5, I guess there. And I'm not looking for art. Remember, I'm looking for that you understand what this is. Each should have a vertex, a place where it turns around, should be in the right place. The y-intercept should be in the right place. If it's got x-intercepts, they should be in the right place. And it should have the right shape. It should be symmetric. This isn't a sharp corner here. It's a nice round curve. And that's it. You do not need to graph the axis of symmetry, but it should be symmetric across that line. And that's all there is to graphing the parabola. That's all the stuff we need. Let's do one more so we get a look at one of these upside down ones. Remember, the vertex x-coordinate is going to be at negative of b, which in this case is negative 6, over 2 times negative 1. So that's 3 negatives. We're going to end up with a negative there, and 6 divided by 2 is going to be 3. So the x-coordinate of our vertex is going to be at negative 3, and we use the calculator to find the y-coordinate. So let's go plug this in. It's negative x squared minus 6x. What was it, plus 3? Okay, and then we get that on our graph screen. Okay, looks like our y-intercept, trace 0, is 0, 3. We really already know that because that constant is always going to be our y-intercept. So let's put our y-intercept at 0, 3. Our x-intercept, not our x-intercept, sorry, our vertex is going to be at negative 3, 12. Oh, 2 12s in a row in here. So negative 3, 2, 4, 6, 8, 10, 12. It's going to be up there. And then let's look for our x-intercepts. Looks like that x-intercept is between 0 and 1. And that one's between negative 1, 2, 3, 4, 5, 6, and negative 7. Those are not nice intercepts. They're not whole numbers, so I really don't care that much about them, but they need to be in the right place. So your intercept here needs to be between 0 and 1, and then negative 6 and negative 7 there. That's where the other one is. Okay, so they don't have to be precise unless they're nice numbers. If they're nice numbers like they were here, then I want them precise. But if they're not nice numbers, then there's no need. And then we've got our symmetry about that axis there, the vertical line, and the vertex should be the highest point on the graph. And like I said, not that bad. One small formula, and that finds the vertex for you, and then just using the calculator for the rest. The important thing is that you know what the important stuff is. You know the x-intercepts, the y-intercept, and the vertex are the important aspects here. I do want to show you, if we didn't find that x-coordinate of the vertex by using the formula, if you look at your table, you should be able to see that symmetry, right? So negative 3 is 12, and then negative 4 and negative 2 on either side are at 11, and then 8s, and then 3s. So you can see where those numbers change direction. They're increasing here, and then they start to decrease, and that's exactly what happens with the graph. So that's graphing quadratics.